Hey everyone, welcome back to the channel. In my previous video, I dived into a fascinating world of expression with Fusion, focusing on connecting node values and manipulating them to create a dynamic animations. I drew parallels between this process and the dynamic relationship between a television and a remote controller. Building on that analogy, I'll provide a quick recap before diving into using formulas for precise and targeted animation. Stay tuned as we explore the power of formulas in achieving the animation effects you desire. Let's elevate our Fusion skills together, starting with an example of myself and my friend Goku. Imagine I was given an instruction to eat whatever Goku eats. In this scenario, I'm going to designate Goku as a separate node and the other node as myself. As a matter of fact, let's jump into the computer and do just that. So let's quickly build a Fusion composition. Right click on the media pool, create a Fusion composition. So I'm going to name this Goku. Okay, so we have created Goku. So let's drag this to the timeline and we're just going to do this quickly. And we are going to go to the Fusion page because we've done this a million times. So we don't need to do that again. So I'm going to create two rectangular nodes and I'm going to name one myself and I'm going to name the other Goku. All right, let's do that quickly. Okay, if you want more details on how to do this, you could check out my previous videos and I explain this in details. So I'm going to be working a bit faster here, but I'm still going to explain what I'm doing so you could be aware of everything. All right, so create a rectangular node here, create a rectangular node here. So I'm going to name this Goku, okay, and I'm going to name the other one myself. So I'm going to change myself to a different color so we can differentiate between myself and Goku. So I'll go with green, okay, and I'm going to change myself to 0.25, enter, and I'm going to change Goku's X value to 0.75. So I did that so that we could be side by side. So you could also follow me through this journey. Okay, so make it that easier. So since I'm the one following the instruction, it implies that the instruction will be written in myself node. Okay, so I'm the one following the instructions. So I'm given the instruction. So I'm the one who's going to be doing whatever Goku does. So Goku and myself need to communicate, right? Now, in order to communicate, you need to speak a language. Okay. DaVinci Resolve uses the lower programming language. Okay. So in this case, remember I gave an example. What if I've been instructed to eat whatever Goku eats? So let's say that was the case, right? And I'm trying to write that expression using lower language. Okay, so I know the name of the person, right? Which is Goku. That's the expression that you're going to use to tell myself what to get from Goku. So that'll be Goku, which is the name of the person first. In this case, the name of the node. I'm going to write, remember, I'm a different node, right? So you're going to specify that node, which is Goku. So Goku now dot food. Food becomes the parameter. All right, so the parameter is food. So if you say Goku.food, that means whatever Goku eats, now I eat. Cool. So if you want to be more specific, you could say whenever Goku eats rice, I eat rice. So now that becomes Goku.food.rice. Simple. So now whenever Goku eats rice, I eat rice. But if Goku eats something else, now I do not have to eat whatever else Goku eats because I was given the instruction to only eat rice when Goku eats rice. Okay, so now I'm free. I could now eat whatever except when he eats rice. I could be given an instruction to eat half the rice. Okay, so that becomes Goku.food.rice divided by 2. All right, so now whenever he eats maybe 10 value, then I have to eat 5. Or you can multiply by 2, so forth and so on. So that's easy enough. And that's the analogy that I'm going to use this time. All right, so let's just go into myself and write the instruction. So let's say I'm going to write an expression on the center. Okay, and I'm going to choose the X value. So I'm going to take out the 0.25 because I'm now going to take the instructions from Goku. So simple. Well, let me move this mic. Doesn't matter. All right, so I'm going to type in Goku dot the perimeter center and to be more specific, X dot X. X is capital letter, by the way. Now when you hit enter, boom. Now I have the same value as Goku's. Well, you can't see Goku because now Goku is behind myself. If you want to see Goku, you could go and change the Y value. So remember, the Y value is not connected. So I wasn't instructed to follow the Y value. I'm only following the X value. So I'm only moving the Y value so you could see that Goku is behind me right now, myself. Okay, but if I move the X, we are together. Okay, so now Goku controls my X movement. So and now Goku determines what my X value is going to be. Okay, so now I use that analogy just to drive the point home. Okay, so I've already done this on my previous video. So if you want more details, go to my previous video and rock out. So now let's jump straight into using formulas. And by the way, I did use some formula towards the ending of my previous video, so check that out too. But today I'm going to include more examples, so this way you get to understand a bit more with formulas. So we are going to be using more formulas. All right, so I'm going to start from test node. All right, so test node, I'm going to repeat some of those just to refresh your memory. So we are going to go to test node and we right click expression. So if you recall, we did use time divided by 24. That was the first thing we did. And remember, if you do that, time represents the frame. So if I go to frame 24, it's going to be 1 because 24 divided by 24, 1. If I go to 48, it's going to be 2 because 48 divided by 24 is 2. That's as simple as that goes. Okay, so time divided by 24, time is usually the frame. Okay, so boom, we get down packed. If you want to remove the decimals, you simply use floor, boom, and open brackets and close brackets. We no longer have decimals. Okay, just integers. All right, so that's cool. Okay, so we could decide to play with expressions here now. All right, so we could just multiply time with, let's say, size. We could do time multiplied by size. Boom. All right, so the reason why it didn't work right now is because I used small letter. So in coding, we're gonna have to be precise. We don't have room for error, especially when it comes to spelling, the dots, and all that goods. All right, so I did use small s for size, and if you look down here, it did use capital letter. So we're gonna have to check out for those. Okay, so most times when it don't work, you're gonna have to check back on your spellings and your capital letters and smaller case letters. All right, so now boom. Okay, so that's what happens. So if you increase the size, it multiplies the value of size with the value of frame. Okay, so that's basically what it is. So whenever you increase this also goes up with it as well. Simple, time multiplied by size. Well, you could do stuff like that if you want to, but I highly doubt you're going to use that for anything. Maybe you could do something with it, I don't know. But let me give you something you might use. Okay, so this one is something that is quite popular. So I'm going to introduce a new expression. All right, so this one is time divided by comp dot render end. Okay, so let me reduce the size. So let me explain this just a little bit. Render end, I'm going to use this vaguely. It usually means the length of the composition. Okay, so it's calculating time divided by length of composition. Okay, so that's again time divided by comp dot render end. So comp dot render end becomes very important because it's not just time that you could use it. You could use it with other nodes and other parameters. Talking about other parameters, I'm thinking we're done with text node. So let's use rectangular nodes as we've been using before. Okay, so let's create a background and a rectangular node. So let's connect this. Okay, so this is at 0.5 and 0.5. So this is at the center. So this is perfect. Okay, so now we are going to do some formulas. Okay, so let's try that time with render end with width. Let's see what we get. Okay, so let's try that again. Time divided by render end. Okay, comp render end. Okay, so let's see what we have here. Boom, we have this slow moving animation, and it's smooth as well. By the way, if we go to the length of the composition on the edit page and increase this and go back, it's going to move a bit slower because you've increased the length of the composition. So that means it's going to move slower. If you make it shorter, it's going to be even faster. Okay, so let's go back and try to put it where it was. I think it was right here. Boom, that's cool. That's an example of comp render end. Remember that because that's going to be useful. Comp render end. All right, so most times when you do animation and you want it to still work or still render to the end of your composition, you might want to use that formula. So whenever you expand your composition, it does not stop. It expands to the length of your composition. Boom, pretty important. So keep that in mind. Okay, so let's use other formulas. So to remove expressions, right click, remove expressions. Boom, let's go back to the original size and let's use another example. Okay, so let's introduce a different expression. By the way, let's use the width. By the way, I'm going to provide some sites where you could go and look up these formulas, because these formulas, you don't have to memorize them. There are websites out there that have these formulas where you could copy these formulas and simply copy and paste into your expressions. So no need to memorize them. But if you like any formulas I have here, you could write them down and you could use them for your work if you like. Okay, so let's go with another example. Okay, so this one, I have my note here. So I'm old school. I wrote my expressions on my note. Okay, so let's use Sine. Sine is a formula for angles and all that. Okay, so this is where things are gonna start becoming more interesting. All right, so let's use the Sine bracket time divided by 20, close brackets, then divided by 2 plus divided by 2 plus 0.5, enter. So let's see what happens with this. So this is, as you can see, is like it's bouncy kind of animations. By the way, this animation right now, if you're trying to recreate this, it's going to take a while to recreate something like this. It might require a lot of keyframes. Okay, but I just did this, just putting the formulas. And even if you try to recreate this formula, you might not actually get it as perfect as this. Okay, so this is like a smooth animation. All right, just by using the formula, you get something like this. Boom. So that's cool. Okay, so if you like to use something like this, go look up the formula, or you could write down the formula here. By the way, I'm going to put it on the screen so you could take a snapshot and hey, use it. All right, so let's look for another example. Okay, so we have a lot of those animations, all right, using Sine. Okay, so again, Sine. By the way, Sine is It's a useful formula, okay? So we're gonna use this, 10 divided by 10, close brackets, multiply by 20. Okay, so let's see what this does. Boom. All right, so sometimes it might be too fast or too slow. You could always play with the numbers and see what you get. All right, so I put multiply by 20, so let's try multiply by 10, see how that moves again. Okay, so it's even slower, so let's multiply by 2. Okay, as you can see, it's even slower. Okay, so again, that's another example, and that's the motion that you get with something like this. You could always play with those numbers here, multiply by 1, and just, there you go. You see, this is even slower. Okay, so all right, so let's try this animation with copy. All right, let's stop this. Let's try this animation with center. Boom, expression. Okay, so let's go to the center and let's use the Y. Let's put it on the Y value. Boom, boom. Okay, so let's play that. Boom. So sometimes these formulas work best with certain position. Okay, so obviously you cannot use any formula for every position. You're gonna have to find the perfect position for it. So this seemed like a bouncing type effect on the animation. Also, if you look at the animation, you could see that the value goes to negative, which is why it goes all the way down where you cannot see it and bounce back up. So we have a solution if you want to remove the negative value. We have a formula that turns any negative values to positive. So that's absolute. So ABS and open bracket. So anytime you open the bracket, you want to close it. Open bracket and close bracket. So you hit enter, boom. Now it doesn't go below 0. All right, so now you could see the bouncing effect on the screen. Okay, boom. It's that easy. So like all these formulas, again, they are available on websites. You could Google search, but again, I'm going to provide the sites. Look out for those. All right, boom. Okay, so we have tried the sine, so let's go to cosine. But cosine also has similar effect with sine. Okay, so we are going to use the cosine and let's see the difference between this and the other one. It might be similar, but they might have subtle differences between them. Okay, so anytime you put something wrong, you're going to see these red marks on the nodes. Okay, so what I'm gonna do now is go and just look for what I did wrong. So you're gonna have to be patient if you want to do expression. Okay, and you're gonna have to also problem solve as well, because you are going to run into problems, definitely, especially if you are new. There's no way you're gonna do this without running into problems. Okay, even somebody who's been doing it for a minute runs into problems. So the problem here is because I did 2 brackets, all right, but then I forgot the bracket of the point, closing the entire bracket. Okay, so you needed 3 brackets because we have 1 here for point, 1 here for absolute, and 1 here for cosine. So you needed 3 brackets. All right, so now we could add plus 0.2. Boom. Now it works. Do you see how sometimes it could be frustrating to get the right words sometimes, because I couldn't figure out quickly enough that I needed 3 brackets, all right, because I forgot the bracket after the point. You're gonna have to be mindful of that kind of mistakes. So let's check out how this looks like. So this is kind of bouncy as well, but it has like a little bit of ease in at the top. Okay, so again, there's like a subtle differences between them, but not that much. Okay, we've done some of the sine, some of cosines, and we've done some absolutes. Okay, so now we are going to go into something else. All right, so let's go with the width. this next expression is best done with width. All right, so before that, I'm going to put this back at 0.5. Okay, so I'm going to go back with time again. All right, so let's just do something that requires two different commands. Let's say commands. So I'm going to go time divided by 24. We did that before, right? And we are going to multiply that with time divided by comp render, and boom. Okay, so now what this means is the value depends on two different commands. So the value depends on time divided by 24 and multiplied by time divided by comp.render end. All right, so this is kind of like, okay, so again, this also depends on the length of the composition. Okay, so as you can see, you could make complex animation by combining a lot of stuff together. Okay, you could combine them by multiplying or dividing or adding or subtracting. Okay, so that's cool. So let's use if function. All right, so we're gonna use the if function for this one. Okay, so this one is a bit longer than usual, but again, does it matter? As far as you understand what's going on. So this is going to be my last example. Like I said before, there are so many expressions out there that you could use to achieve whatever animation that you like. But I'm just giving you a few examples to help you understand how to use them. Okay, so let's use my last example, which is going to be the if function. Okay, so the if one, which is kind of, well, with Lua, if is spelled with double I in the beginning, so make sure to include double I in the beginning, because if you use one I, it won't work. Okay, no room for error when you are coding. So the people who actually use programming language a lot, they probably know this. So pay attention to each command. Okay, so this is if, so this is based on condition. Okay, so if time is less than comp.render end, and with render end, arrow have to be capital, E have to be capital. So with condition, it will give you a condition, then it will give you a true value, and it give you a false value. Okay, so now this is saying if time is less than comp.render end multiplied by 5. So that means if comp is less than half the length of the composition. Okay, but if you look at the mathematical formula, it does make sense. If time is less than render and multiply by 0.5. Usually when you multiply anything by 0.5, that's half. That's the same as multiplying by half, 1/2. Okay, so that's just in decimals. Okay, so if that's the case, you have to put comma. The value should be time divided by 24. So if that's the case, then you have to provide another value in case the time is not less than half. So when the time is more than half, what is going to be the value? Okay, so the value is going to be, for that, time divided by comp.render and then you close brackets. Boom. So just thinking about this formula, you could already see that it's like an ease in, ease out type of formula. So one is half the length and one is full length. So you already know the speed is going to change halfway. Okay, so when you play it, you see that. Well, let me reduce the screen so you see what's going on. Okay, reduce the screen. So you see, like, boom. Okay, so it has two different speeds. All right. Yeah. So, boom. Well, you could think of different things you could use that formula to do. Okay, your animation is going to be a lot better, a lot smoother, and you could make complex animation using just expressions. Okay, so guys, I've come to the end of this video and I hope you understood what I've been talking about or blabbing about. Yeah, but guys, you know, sometimes I know that it's not the easiest thing to do, or it might actually be just annoying sometimes. Believe me, it's annoying sometimes, because sometimes you might make a single mistake. You might not find that mistake readily, because it might just be just tiny mistake you just did, and you'd be like, what did I do wrong? And you keep staring at the formula, you can't even find it. But sometimes you just have to pay close attention to each letter, each word. Okay, that's a trick. Pay attention to each letter, each word. Easier said than done, but sooner or later you are going to get used to it, and you are going to become a pro, and you are going to start creating your own formulas for your own animation based on your own understanding. Okay, boom. Think about it like a language. Okay, it's a language, so you don't have to speak like a lure. That sounds corny, but that's it. So guys, this is it. If you like this video, hit that like button. If you learned something, make sure to subscribe. And if you want to learn something in the future in this channel, hit that notification bell so that you could be alerted when I drop my upcoming videos. So guys, I've done 2 parts on expressions. Okay, so I might do one more, you know, or 2 more. Okay, so be expecting 1 or 2 more on expressions, because I think people should learn expressions. Okay, especially if you're seriously into editing, you should learn expressions. Okay, you don't have to, but if you want to get to that level that you need to be at, learn expressions. Okay guys, I've taken much of your time. I will catch you on the next video. Peace.